All right, in this lesson, we're going to be talking about transformations of functions. So the objective is we are going to graph functions based on the parent functions and their transformations. So in this lesson, you really need to know the pattern that we learned from parent functions. Okay. So let's start out with talking about the horizontal shift. So here is a parent function, and just by looking at this, you should be able to graph them, but I'm going to go over that one more time with the table of values, right? So there's, if you put 1 in for x, absolute value of 1 is 1. If you put 2, absolute value of 2 is 2. Okay, you put 0, you get 0. If you put negative values, you get back the same value, but positive, because that's what absolute value does. And then let's put that on the graph, right? So we got 1 1, negative 2 2, 4 4. I'm not going to put all the points on there, but hopefully you guys get the point. The graph looks like a V shape. Okay, so that's the parent function. Now, what would happen if I put things into there, into the function? I add numbers in. For example, I'm going to do that. So I put a negative 3 or minus 3 inside the absolute value. Let's think about this now. So if my y is still 1, I need to put 4 in for x instead of 1, because 4 minus 3 is now 1. Does that make sense? Instead of before I had 1 for x, now if I wanted the same thing, I need to put 4 for x, because 4 minus 3 is 1. Absolute value of 1 is 1. Same thing, if I want to keep my y at 2, I need 5 for x. 5 minus 3 is 2. Absolute value of 2 is still 2. If I wanted 0 for y, I need to put 3 in. 3 minus 3 is 0. You see? If I wanted negative 1, you see, then I put 2 in. 2 minus 3 is negative 1. Absolute value of negative 1 is 1, and so on. So you can see that all my x values are now 3 units bigger. So what happens is, if all the x values are 3 units bigger, it shifts the graph, right? So the graph goes to the right. So now all the x values get a little bit bigger. Instead of negative 1, now it's 2, and so on. And we call this, it shift right 3 units. Okay, because of that minus 3, we go right 3. Now let's look at the vertical shift. So here I have my parent function back like before. This is just a basic parent function. What happens if I put in a number not inside but in the back, right? Not in the absolute value but in the back, minus 3. So imagine if I put 1 in for x now, I get absolute value of 1. So I'm talking about this point here. If I put 1 in for x, absolute value of 1 is 1. 1 minus 3 is now negative 2. Right? So instead of 1, I have negative 2. If I put 2 in for x, then I get positive 2 minus 3 is now negative 1 instead of 2 earlier without the minus 3. So if you can see what happens here, all my y values get lowered by 3. Instead of 1, now it's negative 2. Instead of 2, it would be negative 1. That's a mistake right there. That should have been negative 1. But you can see the point. Now all my y values get lowered. So what happens to the graph? The graph goes down by 3 units everywhere. Right? So my values all change. So that is called the transformation is called the shift down 3 units. That's what's happening. Okay. Let's move on to what we call the vertical reflection. And what it does, or when that happens, it's because I have a negative number in front of my function. Okay, so if I have a negative number, let's see what happens. If I put the same number in for x, like 1, absolute value of 1 is positive 1, and I have negative of positive 1 means negative 1 now. See? So all my values on the y becomes the negative of what it used to be. Okay? 1 becomes -1, 2 becomes -2. That's for my y values. So what does that do to the graph, right? All the y values up here now will be down here. Positive y goes down to y, but it stays in the same x, okay? So your graph looks like that. It just flips it over, okay? It flips it upside down, and we call this reflect across the x-axis, okay? That's a reflection. If you have a negative number in front, it's a reflection across the x-axis. Now the vertical stretch and shrink here again is the original graph, right? If I put a number that is not 1 in front, okay, number in front that's not 1, like I put 2 here. Imagine you put 1 in for x, you get absolute value of 1. You would have gotten 1 without that 2, but now that 2 multiplies it, so now you get 2 instead of 1. Right? So that 2 multiplies your values and give that to the y. Now y's are twice as big. All the y values are twice as big. So 2 times 0 is still 0, but 2 times 1 is 2. 2 times 2 is 4. So what does that do to the graph? All the y values get twice as big. So it goes up and up and up. So your graph looks like that. Okay. That's a vertical stretch or shrink. So let's put all this together in like a formula, okay? Oh, by the way, that is called the vertical stretch of a factor of 2, okay? Vertical stretch of a factor of 2. All right, put it all together, and this is like a general formula for transformations, right? So you have 3 things that could be happening to your function. One is, the thing inside your absolute value, and then the next is the thing outside here, and the last thing is the thing in the back. Okay, now what's important is that you guys have to remember is that the order matters. If you do this out of order, it'll give you the wrong graph. Okay, so you got to do it in order. So the order is this: you go with the one inside. It's like a order of operations, right? So if you do this is like parentheses. The absolute value is like parentheses. So parentheses goes first, h goes first, and then the a, and then the k. Okay, so first is the h. H is the translation horizontally. If h is negative, it goes right. If it's positive, it goes left, basically, this number right here. So this number, if it's negative, it goes right. If it's positive, it goes left. And then next would be the one out here, because order of operation, multiply by a first, and then you add k. So multiply by a. Now a is a little bit confusing. There are 3 things that could be happening with a. If a is greater than 1, if the absolute value of a is greater than 1, that means you ignore the sign, right? If it's negative, just ignore it. But the number itself, if that number is bigger than 1, it's a stretch by a factor of a, because it multiplies that number. And if it's bigger than 1, the number gets bigger, so it's a stretch. This means stretch up and down, right, vertically. So your graph gets stretched up and down. And then if a is less than 1, absolute value, okay, not talking about negative. If the absolute value of a is less than 1, meaning it's like a half or 2/3, then it's a shrink of a factor of a, okay? And if the number itself is negative, meaning if it's less than 0, if a is negative, then it's a reflection across the x-axis. And then the last thing you do is you look at the k in the back. K translates the graph vertically, k units. If it's negative, it goes down. If it's positive, it goes up. So put all this together. Ooh, what is that? Okay, so this is the combination of all the transformation that we might have, right? So here is my function, and I'm going to look at the parent function first, and that is for just x squared, right? F of x is equal to x squared. This is a parent function. You got to know the pattern, right? 0, 0, 1, 1, 2, 4, 3, 9. That is just for f of x is equal to x squared, nothing else. Now we're going to apply all these 3 numbers and see what it does to the graph. Okay, the first thing we got to do is inside parentheses, so plus 1. Let's see what that plus 1 does. Now here you have x plus 1, but x plus 1 is x minus -1, because the formula says x minus something, right? And this is actually a -1. So just think of it as the opposite sign of this. If this is positive, it goes left. So it goes left 1 unit. All right, so your graph goes like that. And your values get changed. All the x goes down by 1. Instead of 0, 0, now it's -1, 0. Instead of 1, 1, now it's 0, 1. 2, 4, now it's 1, 4. So pay attention to how the values change as we shift our graph. Okay? And then the next thing we got to do is look at the -2. What does -2 do? A few things. Is it positive or negative? It's negative, right? It's less than 0. It's negative, so it reflects across the x-axis. So you turn the graph upside down, and it goes down like that, right? Okay? And all your y values become negative of themselves. It used to be +1, now it's -1. It used to be +4, now it's -4. Okay? Now, look at the number itself. Ignore the sign. Is that bigger or smaller than 1? 2 is bigger than 1, right? So it's a stretch. Right? So absolute value of 2, -2 is 2. 2 is bigger than 1. It's a stretch of a factor of 2. So what does stretch mean? Vertical stretch. So you stretch it up and down. So now it's longer vertically. So it looks like this. All right. You see? Now, this was -1. Now it's -2 because it got stretched by a factor of 2. So you just basically multiply your y values by 2. And the last thing is +3. That means that you got to move it up 3 units. Like shift up 3 units or translate up 3 units. Same thing. So your graph goes up 3 units. There we are.